Welcome back. In this part of the Exam 3 review, we are going to look at what happens when rational expressions show up in equations. And equations have equal signs, expressions do not. So when we have just expressions, we simplify. When we have equations, we simplify the expressions that might be on either side of the equal sign, and then we solve for the variables, find out what values of variables make the equations true. So a key word is solve. If you simplify and don't solve, then you won't be doing the problem correctly. So in this equation, we have the expression x minus 24 over x equals negative 2. So first let's simplify. First let's set the equation equal to 0, because ultimately we want to have factors that equal 0, and then we can use the zero factor property. So we are going to add 2 to both sides of the equation, and we get x, and I'm going to put the 2 with the x like that. Now I have an expression on the left that I need to simplify. That means I need to combine x plus 2 minus 24 over x. And the way I do that is I make x plus 2 into a fraction. You could have done it separately. You could have said x over 1 plus 2 over 1. But since they are both over 1, I might as well combine them. And then our common denominator is going to be x. So we multiply the first by x over x, and the second term we don't have to multiply by anything because it already has x. So that gives us x squared plus 2x for the first denominator, minus 24 for the second denominator, and all of that over the common denominator. Okay, that's our first step. Let's review the steps for solving a rational equation. First, you set it equal to 0, as we already did, and then you simplify the rational expression on one side of the equation into one fraction, which is also what we did. What we are about to do is determine what values for x are not allowed. So to do this, we look at the denominator, and whatever makes the denominator 0 is not allowed. In this case, we only have x in the denominator, so x cannot be 0, which means our domain is all values of x such that x does not equal 0 will work. And we circle that because at the end we're going to check our solutions against this and discard any solutions that are equal to 0. Okay, so we've determined that 0 is not allowed. Now we can discard the denominator and solve this problem. Okay, so to solve this, we're going to factor, and we can see there are no greatest common factors. It is not a special case because it is not a binomial, so it can't be a difference of squares or cubes or a sum of cubes. This is not a perfect square, so it isn't a perfect square trinomial. So it's not a special case. Then we ask ourselves, is there a number other than 1 in front of the x squared term? And there is not, so we can use reverse FOIL. So we come over here. We want two numbers that multiply to give us negative 24 and add to give us 2. Well, 6 times 4 is 24, and its difference is 2. And if the 6 is positive and the 4 is negative, they'll multiply to give us a negative number and add to give us a positive number. So we write those numbers down. And now we have factored the numerator after discarding the denominator, And so we apply the zero factor property to solve for x. And the zero factor property says if all of this equals 0, then this has to equal 0, or this has to equal 0. So in the first case, x would equal -6, and in the second case, x equals 4. So our solution set that we found is 6 and 4. But we need to remember our last step, which is to discard any solutions that are not allowed. Well, x cannot equal 0, but that's not in our solution set, so we don't have to discard anything. And our answer, I'll write it up here in case you can't see it, our answer is the set containing 6 and 4. Now remember, we need to read the instructions, and in this case the instructions state that we should not solve the equation. So without solving the equation, we are to choose what solutions cannot be used, so whichever ones we must reject, and then we are to find the domain. So the ones we are to reject are the ones that make anything equal to 0 on the bottom. So let's go ahead and find the least common denominator, which is easy to find. It's 5x plus 7 times x times 6x minus 8. So normally we would multiply the numerators by the missing factors and get a complicated thing in the numerators that we have to solve. But in this case we don't have to do that because we're not to solve it. But we need to find out what would make this denominator equal to 0, which would require us to divide by 0. So we have to find that out so we don't end up dividing by 0. We have 5x plus 7 equals 0, x equals 0, don't forget that x, or 6x minus 8 equals 0. So 5x equals -7, and then dividing by 5, x equals -7/5. We've already found that x can't equal 0, and so 6x equals 8, so x equals 8, 6, and reducing that, x equals 4/3. So the three values that x cannot equal are -7/5, 0, and 4/3, and it doesn't matter what order you write these in. And the way you write the solution set is you do a bracket x such that x does not equal -7/5, 0, 4/3. I call this a solution set. That's not what it is. These are not the solutions. What it's telling us is what the solutions can't be. So this set here is called the domain. And when they ask for the domain, they want it in set notation. To solve for x in this equation, first we need to set one side to 0. So we're going to subtract everything on the right side from both sides, and that'll give us x minus 4 over x plus 6 minus 2x plus 3 over 2x minus 1. Now we need to combine those to make one fraction, and to do that we need the least common denominator, which in this case is going to be the product of the two denominators. So to get the least common denominator for the first fraction, let's go ahead and enclose all of our binomials in parentheses. We need to multiply top and bottom by 2x minus 1. And for the second one, we need to multiply by x plus 6. So let's go ahead and rewrite that. We have 2x minus 1 times x minus 4 minus 2x plus 3 times x plus 6 over one denominator, our least common denominator. Okay, let's look at that numerator. We are going to keep this in brackets as we simplify. And at this point, before we FOIL, we can go ahead and figure out what our domain is so that we know what values of x are not allowed. So in order to do that, we take our denominator here, or our least common denominator, and we use the zero factor property. We don't want our denominator to equal 0, so that means x plus 6 can't equal 0, so x can't equal negative 6. It also means 2x can't equal 1, or x can't equal 1/2. So our domain is that we can use all values of x except for negative 6 and 1/2. So we're going to circle that in red and come back to it. And at this point, now that we've figured that out, we don't need the denominator anymore, because the only reason we needed the denominator was to know what values of x would make it 0. Now let's work on the numerator. We're going to FOIL 2x minus 1 and x minus 4, and we get 2x squared minus 8x minus x plus 4. And then we're going to keep that minus sign, and we're going to keep this all-important bracket because it keeps us from making a mistake with negatives. When we FOIL what's inside the brackets, we get 2x squared plus 12x plus 3x plus 18. All of that equals 0. So let's go ahead and combine our middle terms. 2x squared minus 9x plus 4 minus bracket 2x squared plus 15x plus 18 equals 0. And now we can distribute this negative sign, which means change subtraction to addition like this. Add a line and change the sign of everything in the brackets. So now we have 2x squared minus 9x plus 4 plus negative 2x squared plus negative 15x plus negative 18 equals 0. And we can combine like terms. 2x squared minus 2x squared is going to be 0. Negative 9x plus negative 15x is going to be negative 24x. And 4 plus negative 18 is negative 14. So we can pull out a 2 from that, and we have negative 2 times 12x plus 7 equals 0. If we divide both sides by negative 2, we get 12x plus 7 equals 0. And so 12x equals negative 7, and x equals negative 7/12. So we think that's our solution. The only way it won't be our solution is, assuming we haven't made a mistake, is if negative 7/12 is not allowed. So we go look back to what we had before. Let's move everything down so we can do that. And we see up here, here that x cannot be -6 or 1/2. But x can be -7/12. It can be anything else except that. You can find a solution anywhere else in the domain. So our solution is -7/12. Now that we've done that, we no longer need our denominator x minus 3 times x plus 3. And think of it this way. If you multiplied everything on both sides of the equation times x minus 3 and x plus 3, you would clear the denominators and you would still have 0 on the right because 0 times anything is still 0. So our denominators our new equation is going to be x times x plus 3 plus 4 times x minus 3 minus 18 equals 0. So let's go ahead and distribute so we're going to combine like terms. And that's the trinomial we end up with. Is it factorable? Let's check that out. We can go through all of our cases. There's no greater common factor, no special cases, no coefficient in front of the x squared term other than 1. So we can use reverse FOIL. We need two numbers to multiply to -30 and add to 7. Well, 10 times 3 is 30, and the difference between 10 and 3 is 7. And if we make 10 positive and 3 negative, we'll get what we want. So we rewrite this as x plus 10, x minus 3 equals 0, and we come out with the solution x equals -10 and x equals 3 as solutions. Except we need to check and make sure neither of these values are excluded, and sure enough the 3 is excluded. So we discard that solution and our final solution is going to be -10. Here's another problem where you really want to be careful to read the directions. First, list the numbers which would have to be rejected as solutions, then give the domain in set notation. So don't worry about the f of x in front. That doesn't mean you subtract f of x from both sides. It's just telling you that the function is 7x minus 5 over 4x plus 3, and we're going to call that f of x. But we need to know what x cannot be for this function, and so we set the denominator equal to 0 and solve for x. to find what x would have to be to make the denominator 0. So the first part of the answer is that x cannot be -3/4. So notice that if this problem had been 5x to the 15th plus 3x squared minus 17 over 4x plus 3, you would still get that x cannot equal -3/4 because that's the denominator is the same. And so it doesn't matter in this kind of problem where they just want the domain and they want to know what values cannot be included. It doesn't matter what the numerators are. You're not going to use them at all. So, we don't need this anymore. Let's see if I can erase it. I can't. So I'll just cross it out. Alright, so we can go ahead and write down in set notation what the domain is. And the domain is that every value of x is allowed except for x equals -3/4. Okay, now let's go on to part 4 of the Exam 3 review.